I'm going to do is draw an axis, an XY axis real fast. And I want to talk about quadrants. Do we remember our quadrants? What's this one?
1. 2. 4.
See if you're paying attention.
3. 2.
Okay? This Rocky movies and Star Wars are the only times you're ever going to use Roman numerals. Let's see, the other thing. This is 0 degrees. This is?
90. Well, is it 0? Negative 90.
It's your starting point, yes, you're 0. And then 360. That's where we're going around like this, correct?
One of them James goes.
The 0 wasn't there. Now, as you count through these things, what happens is, excuse me, your angles, when we're working with angle measurements, we have a starting spot. We always start on the positive x-axis. And if I want to draw, let's say something that's 110 degrees. When I draw an angle that's 110 degrees, let me move this swirl out of here. We start it here, and it comes up past 90 and about here. Close enough. What happens is, this part here is called the terminal side of an angle. It's the terminal side of an angle. It's where the angle stops. We all remember from geometry last year that angles are made up of 2 rays. Rays are the sides of the angles. The vertex for this angle is located at the origin. Very good. Say located at the origin. Now, the one side will always be the positive values of x. It goes from 0 to the positive side of x on the x-axis. The other side is called the terminal side. It's how much of an angle is it as it's opening up. It always, as we're talking about positive angle measurements, we're always going counterclockwise. Okay? If I wanted to say we had a 500 degree angle, again, I would start here, 90, 180, 270, 360. What's 90 more than 360? 450. So I go about 50 more.
Yeah.
And there's my 500 degree angle.
Whoa.
Notice I'm spinning it around.
Is that legal?
It is.
No.
Okay?
That's very rough. That's not legal.
What we're doing here is we're setting up to show what quadrant an angle, what quadrant the terminal side of an angle lies. So if I ask you to draw a 700 degree angle, what quadrant would it lie in?
It'd be
4.
in
1.
No, it'd be in 3.
1.
3. It'd be in 3. It'd be in 3.
Yeah, well, let's see.
3. Man, I know from skateboarding. That's 720 right there at the top down line.
All right, so we go, there's 360.
That'd
That'd be 720, so it's in here somewhere, right?
Oh, I got
So
it.
what quadrant is that? 4. Very good. I'll give him something. I'll give him a bit. He actually remembered something from skateboarding.
Tony Hawk Underground.
Yeah.
Sickest game.
I can go for that.
Xbox original.
All right. Now,
Actually, I can.
gentlemen, not only are there positive angles, but there are negative angles. Negative angles just go the other direction. Instead of going counterclockwise, they are going clockwise. So if negative 40 degrees, I start at my 0 and I go down 40 degrees. What quadrant does that lie in? 4. Good. So that's quadrant 4. So let's take that a step further. What would be the positive angle of 40 degrees? How much? 320. Very good. How did you figure that out? Right. What's happening here is that you can find positive and negative angles that have the exact same terminal side. The positive angle that has the same terminal side here would have been 320 degrees. Basically, like you were saying, all you had to do is just go the other direction. Where are you going to wind up? A nice shortcut way of doing that is just adding or subtracting 360 degrees to get you there. Two angles that share the same terminal side are called coterminal.
And is that for every number coterminal number?
What do you mean, Willis?
Well, if they're, well, yeah, they have to, right?
What?
But 90 has a coterminal number, right?
What would it be?
Negative 270.
Very good. Very good. What would be a positive coterminal angle of 90?
90.
What would be another? All right, 90 is 90, but what's the positive coterminal of 90?
4. Blue.
Well, to get negative 270, what did you do?
I added 2 to 360.
Okay.
Oh, so it would be. Give me a second. I don't know if I'm doing this right. 650? No.
Very good. 450.
That's what I said.
Remember, what you're looking at here, if we're talking about coterminal angles, if you're on your the 90-degree angle, like you were saying, if you were at 90 degrees, the next positive coterminal angle would be just to go around again by adding 360 degrees.
Visuals help.
It does. If I wanted to go the other direction, the negative value, I'd come back this way. And how am I? Oh, I'm sorry. If I wanted to get the negative angle, how many degrees is it to get to there?
I wish I could do this on paper.
To negative 270. Okay. Does that make sense?
Yeah.
Yes, sir.
I think we all need mini smart boards.
Yeah,
Yeah,
so much
how cool
easier.
would that
just
be?
So much
or just do it on your
easier.
paper.
So
and you can
nice.
get rid of this.
So then all the notes you take automatically appear. We don't need that.
I know schools that have like iPads that connect with their smart board.
What,
Yeah, that would be
what
so
school?
cool. St. Charles.
You guys, I don't know if I've told you guys can download smartboard software for free. You could put the smartboard software on a tablet.
On like an
Really?
iPad, iPhone.
I don't think you can do it on the iPhone. I don't think it's
No, but it does work on
Let me see it.
the. No, you have to have the software licensing. I'd have to get you the code. We have at the school a couple thousand site licenses to be able to download this on your own personal computer if you wanted to. I do believe that I can't just automatically, my notes won't automatically show up on your device, but I could email or post the notes when they're complete and you can open them. With the stuff the way that it's set right now, the only thing I can do as far as posting notes would be to create PDF files and put them all as Adobe files, and you guys could open them that way. Like it would just look like a slideshow.
Yeah, like last year, Seb had, remember the little link they
Yeah.
had in the back, and he just write on it,
Yeah.
and it would go up on the smart
Yeah,
board.
the
Oh, I use that too sometimes.
Yeah, he didn't use it a lot, but
Yeah, I like that a lot. I do like it, but with stuff like this, it's a lot easier just to ski right here to make sure you guys are going through it. Anyway, so coterminal angles are basically found by just adding and subtracting multiples of 360. It'll ask you sometimes to find a positive or a negative coterminal angle. It is relatively straightforward. Questions on that? All right. Well, let's start building probably the most important thing we're going to learn. How many degrees there in a circle? Okay, 360 degrees. All right. What is the formula for finding the circumference of a circle?
R squared.
That would be area. 2 pi r. Circumference is the distance around. It's 2 pi r. Very good.
Or rather than pi.
My circumference is
Very nice. Now, here's what I want you guys to think of. If I tell you that your radius of a come on. If I tell you that the radius of the circle is 1, what's the circumference?
Pi.
6.28.
2 pi. Remember, the circumference of a circle, the distance around the circle is 2 pi r. The radius is 1, the circumference is 2 pi. Yes, sir? Oh. Now, if I go from all the way around my circle, I start at 0, and I would end, oops. I would end,
God, send let there be circles.
I would end at 2 pi. 360 degrees is the same thing as saying 2 pi. It's 1 full revolution. Therefore, at 180, what would it be? Pi. Pi. At 90, what would it be? Half pi. Good. Pi over 2. At 270, what would it be?
3/4.
3/4 or 3 halves? 3 halves. Okay. Now the rest of this. The rest of what we're developing here is called the unit circle. The unit circle is based upon your special right triangles. What were the degrees of the special right triangles that we always worked with? 60s and 30s and 45. So we had the 3. Would not be a bad idea. Probably doesn't do that.
Wait, so you get 3 pi
Yeah, 1.5 pi. Now, what comes first? 30, 45, or 60? 30. So this is my 30 degrees, 45 degrees, and 60 degrees. Okay. What would be the measurement of 45 degrees? And I'm sorry, what would be the measurement of 45 degrees in terms of pi? What was it? Very good. How'd you figure that out? It's half of 90. Everybody okay with that? So pi over 2, half of that would be pi over 4. What would 30 degrees be? No. Pi over 6. It's pi over 6 because what is 30 degrees in relationship to 90 degrees? It's a third. 1/3 of 1/2 would be 1/6. Everybody okay with that?
Yeah, so that's 60
It's pi over 6. And what was 60 then?
pi
Pi over 3. Very good. What you guys were doing in your heads was calculating radian measurements for degrees. Radian measurements are all in terms of pi. That's why when you have if you hit the button that says radians, if you take, let's see, if you take your calculator, put it in radian mode real quick, and I'll show you a little trick. I want you to put it in radian mode. And I'd like you guys to type in, let's see, what would be the real easy one? Sine of 45.
Oh, it's a point.
What is it? 0.8. Okay. Multiply that by 4.
It's 3.4.
Turn up.
3.403614.
You can just got 2 different numbers.
So we multiply it by 4, right? Sine of 45 multiplied by 4 is 3.4. Yeah, that's right.
Worked out the other way.
I got 3.4.
Oh, you know what? That's fine.
Did you put it on radians, boys?
Yes.
That's
Oh.
what I got.
I was going the wrong direction. I was thinking something different. All right, again, type in sine of 45, and you got some crummy looking decimal, right? Multiply it by 2, square it.
That's pi.
That's 2.8.
2.896.
Why is this working out cleanly?
No, we don't have to.
Pi equals.
Put it in radians.
It is.
You should be getting 2.
No, it's not.
Well, then don't listen to me.
Wait, what are we so?
I was trying to show you how that would work. I was trying to show you the sign.
Something's
I don't
wrong.
think.
Legal.
Oh, you know, all right, I know why. I guess I didn't. Oh, I tagged you in radian, and I didn't tell you to put it in terms of pi. Never mind. We'll worry about this later. It's no big deal. It does. It has no bearing upon what we're working on right now. I was just trying to show you a little trick. Don't worry about it right now. Now, here's what I'd like to talk about. I want to fill in the rest of this, and what I want to do is I want to show you guys how this stuff is built.
Oh,
Will service
It looks like a
you're missing that.
Jim.
Did you guys send one over for those? So, guys, come on. What I want you to see is I'm not going to look at the 45-degree angle right now because that's kind of the oddball. Going from 0 to 30 is how much? I'm talking just degrees right now. 30 degrees, 30 to 60, 60 to 90. What would be the next one? 180. Then what?
240, 70, 360.
Okay. What you're doing here as you're walking around that, I did not worry about the 45-degree angle parts yet. The next ones, the ones that are in between the 120 and the 150, well, this goes 45, 90, 135. 210, 240, 300, 330. Notice how it's halfway between all of those?
Later.
Okay. Now, let's fill in the radian part in terms of pi. If I go from 0 to pi over 4 to pi over 2, that's adding pi over 4, right? Pi over 4 plus pi over 4 would be 2 pi over 4, otherwise known as 1/2. 1/4 plus 1/4 is 1/2. Okay? Well, 1/4 plus 1/4 plus 1/4 is how many fourths?
3
So this would be 3 pi over 4. Add another fourth, you get 4 pi over 4, otherwise known as pi. Bless you.
Thank you.
Add another fourth to it, you get 5. Yeah, 5 pi over 4. Add another fourth to it, you get 6 pi over 4, which is simplified fraction of 3/2. Add another pi to 6 pi over 4, you get 7 pi over 4. What we're doing here is we're easily and quickly converting degrees to radians by using the following formula. And this works for all of us. Take your angle in degrees times pi over 180. Basically, all you're doing is you're dividing by 180 and slapping a pi in the numerator.
That equals a radian.
That equals a radians.
Let's say pi over 180.
Yeah. Angle in degree times pi over 180 is radians.
What is that? What is the radian?
What?
Why do you use radians?
The rest of the world uses radians. Everything else is dealt with in radians, just like the rest of the world uses the metric system.
Wait, how are radians? Oh, they're used as
Instead of degrees.
What? Why are we
That's
so
weird.
odd? This is gonna screw us up when we become international chemists.
Yes.
after angle?
Angle in degree. So now let's think about the 30s and the 60s. 30, I went pi over 6. 60 was pi over 3. 90 is pi over 2. You're adding 1/6 each time. So 1/6, 2/6, 3/6, this would be
4/6.
otherwise known as
2/3.
2/3 pi. Very good. This would be, remember, 1, 2, 3, 4, 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6 simplifies to be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi. What we're doing here is we're developing that unit circle. We're going to start to look at all of these angle measurements in terms of pi.
Okay.
And we're going to be using radians pretty much from here on out. Today we're going to do some exercises with converting them back and forth into degrees and into radians, and starting to build up this unit circle. We're going to, as we get into the rest of this chapter, you're going to see how these radian values are going to drive everything that we do. Okay? So we've gone from degrees to radians. How would you go in the other direction? Okay, how would you do that?
Divide it by 5.
What is 300 equal?
300 was 5 pi over 3.
Multiply by 180 divided by 5.
Yeah. Good. And then to go from radians to degree, you multiply by 180 and you divide by pi. And like I said, as we get further into this, you're going to be using less and less of your calculator, which I will let you know, there will be non-calc. Probably a lot of non-calc when we do this stuff.
Cool.
All right?
Say my bad.
So let me show you guys a real. Does everybody have this written down?
Yes.
This was one, right?
Mm-hmm. What I'd like you to do is take a minute, and I want you to convert 110 degrees into radians, and then convert negative pi over 9 into degrees. Yeah. Remember, 110
That's right.
times pi over 180. What you're doing here is simplifying a fraction.
Thank you.
Okay? You're just simplifying a fraction. All right. As you go into go in the other direction, recommendation when you have negative angles, especially in radians, it's a fraction. Put the negative in the numerator. All right. And here again, you're multiplying by 180 over pi. What's pi over pi? 1. So since it's negative, I know I'm going to have a negative result. 9 goes into 180 how many times?
20.
20. So it's negative 20. What is the positive terminal angle to negative 20? 340. Very good. What is the negative coterminal angle to negative 20?
It is 700.
you're good. Negative 380. You're spinning around too many times. When you're dealing with coterminal angles, you just want to go one way around and the other way around.
Okay.
There are times that you want to, if you're given an angle that's like 800 degrees and it asks you to find the positive and the negative coterminal, you're always going to find it when the answer is between 0 and 360, going positive or negative. So you might have to subtract it a couple times to get down there.
Yeah. So you just add or subtract
360. Yeah. Again, another quick, real easy example. If I want to find the coterminal angle of 80 degrees, the coterminal, if you want to visualize, because I know that's what you guys do, it's here. The next one is add 360 degrees to that. All right. If you wanted to go the other direction, you're you're subtracting 360.
Wait, if that was negative 80, would you?
This will be down here. The other one, where people have issues, is let's say it's 1,000 degrees. First of all, we got to figure out how many times around that is.
It's a little less than 3.5.
Well, why don't you stand up and start spinning and counting?
3. 360. 720. Right.
980. 980.
What?
A little bit.
720?
900.
Or 920.
1080.
920 and
1080.
Is that 1080 is
1080.
Yeah.
is 3 of them?
Yeah.
All right, so
1080.
so it's down in the 4th quadrant then, right?
then. So I'm off.
Okay.
That's 14.
So 1080 would have gotten us back up here, so we're 80 degrees below that.
Oh.
Oh, this is expensive. Did it shatter?
No, that's just the case.
Oh, I thought it was the same thing.
The moment when I
Yeah.
We need a funeral. It did. It was like. All right.
sounded horrible.
When you're working with the positive and negative coterminal angles, you always want to find them when they're within one revolution, positive and negative. So you would have had to have backed it out 1, 2 to get back in within between 0 and 360. In other words, you'd subtract 360. Are you there yet? So this would be what? 640. Nope. Subtract 360 again. There's your positive one. Does that make sense? You're trying. All right, Daisy. Again, what I'm doing here is I've spun around so many times. In order to find the coterminal that's positive or one that is negative, I'm always going to find that within one revolution positive or one revolution negative. This angle spun around so many times, to find its positive coterminal, I have to unwind it, if you will. I'm unwinding this to figure out where did that land when it spun around. When that one spun around 3.5 times, it wound up down here. Well, the other angle that is just like that is 280. That's why it's coterminal. You're fun as well. All right? And then the other one, the negative, would be just subtracting it one more time. And going from there. All right. Remember, it's very rare that you see the of that large of an angle to find positive or negative coterminal. But if you do, just remember you're just going to continually subtract it until you get within 360 degrees positive or 360 degrees negative. Okay? Let's see, the other bit of this. Well, make sure you have this up there. Does everybody have all of that correct? So make sure you have all that written down correctly. You have all. Yeah, this is bold, underlined.
Is this what our circle is?
This is what your circle is. Okay. I wanted to make sure you have all of that correct on your circle part because, like I said, this is, if anything, this is probably going to be the most important thing that we talk about in this class this semester. In the next 2 chapters, everything we do is going to be based off of these values. All right. It's crazy.
So we need to know this by heart.
Not so much by heart, because if you think about it, you guys picked up on the pattern of it so fast, didn't you? If you're going 30, 60, 90, you're going up by 30 degrees, you're going up by 1/6 each time. So 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, 12 6, get you all the way around. Simplify the fractions. Works
So
every time.
why do we do it different than the rest? Well, I guess I don't know.
What do you mean?
Like, why do we do it different than the rest? Every other country in the world.
The other I'm not going to lie, the other countries use degrees and all that too. But the more you get into the more of the abstract stuff, as you get into pre-calc, calc, everything goes and deals with radians. It's cleaner.
So what about like for temperature? Oh, they use Celsius. We are so.
I knew what you were going to say. You weren't going to say that, but what I want you guys to work on tonight. I'm going to stop here because there's another little bit of this section that we're not going to worry about yet today. I want to give you some practice on this stuff first. And it's on 781. I've got 4 problems for you to work on with positive and negative coterminal. And then 44 through 59 is just converting. You are converting from radians to degrees or from degrees into radians. Please try your best not to do this with your calculator. Try and add and subtract by hand. Try to multiply and simplify fractions by hand. See if you can do it. Because, as I said, as we go into this more and more and more, I'm going to take the calculator away. Okay? Yes, sir.
I won't be here.
What we're building off of this tomorrow is we're going to start talking about how you find your coterminal angles in terms of radians. It's a little bit messier because you have to deal with all the fractions on it. And then how you draw radian or degrees that are in radians. How do you draw that out? It's not going to be that bad. And then we're going to talk about the, remember doing area of a sector last year?
Yeah.
Probably not, but
Like, I remember the name.
you guys used it all with the circumference rules. I'm going to deal with it in terms of radians. Yeah. I'm going to do it in terms of radians, and it's very easy. So it's just a little bit of stuff. It won't be too bad.
Alright, so
Okay.
I don't have to worry about, like,
You can try it. You can take a, I don't know what it is off the top of my head, but I'll have it up on mine. I'm just pausing it.
Oh my god.
You done?